Look up at the night sky, and it's easy to assume the vast distances between planets are just empty space, a featureless void. But that emptiness is built on a hidden architecture. Before we had modern physics, scientists took for granted that space was filled with a physical medium. They called it the ether. The 19th century scientific mind was obsessed with physical machinery. They visualized this ether like a block of gelatin packed with invisible, rotating gears, assuming a mechanical substance carried light waves across the universe. We tried to build the vacuum out of Victorian clockwork. When we couldn't find the gears, we concluded the space was empty. In 1887, the famous Michelson-Morley experiment proved this mechanical gelatin didn't exist. Physics hit a dead end, accepting the vacuum as a void of nothingness. But think about trying to measure a magnetic field with a mercury thermometer. When the temperature stays flat, it doesn't mean the field is missing. You're simply using the wrong instrument to look for the wrong property. Science lacked the right conceptual tools until 1948, when a mathematician named Claude Shannon invented information theory. He showed how any physical process, from a radio wave to a coin flip, could be measured in bits. By defining exactly how data is encoded and transmitted, Shannon gave physics a new vocabulary. We never discarded the cosmic medium. We just finally recognized it was an informational machine. Let's update the terminology. The 19th century ether was a physical substance. The modern ether, spelled AE, is an informational mathematical substrate. Standard modern physics already agrees the vacuum is far from empty. We observe a quantum vacuum boiling with virtual particles, and a Higgs field granting mass to matter. These are structured entities operating constantly in the background of that empty room. The space between planets is an active, dynamic field of information, constantly processing the state of the universe. If space is an informational substrate, then movement and forces might be computational rules. Physicist Dr. Melvin Vopson recently proposed that gravity works exactly like this. This chart shows the second law of infodynamics. As matter objects cluster together, the overall information entropy drops. The universe naturally minimizes its computational load. Think of compressing thousands of scattered data points into a single zip file to save massive processing power. This diagram maps out how that clustering process manifests physically. When particles are scattered, the universe has to track every single coordinate and momentum. As they merge into a single central point, the total information the universe has to process plummets. A sprawling nebula of cosmic dust requires immense computational energy to sustain. A solid planet of the exact same mass, like Neptune, requires a fraction of that power to compute. Gravity behaves less like a physical tug-of-war and more like a hard drive cleanup. The entire universe is actively compressing its source code to minimize the resources needed to track every atom. If everything from a speck of dust to a star is just data in a vibrating informational field, why does a rock feel solid when you pick it up? The answer is phase coherence. Imagine a massive stadium crowd. If everyone jumps and yells at random, it's chaotic noise. But if they coordinate their movements perfectly, a solid, structured wave travels across the stands. In the A model of physics, solid matter forms a reality knot, a localized region where the phase of the vibrational field organizes so tightly that it becomes a stable, persistent structure. Your brain processes that coherent structure the same way a computer monitor processes code. You don't interact with the raw, scrolling text of the programming language. You experience the final, rendered 3D castle. The physical world we touch is simply the rendered output of that perfectly synchronized underlying math. This computational optimization doesn't stop at black holes and planets. It scales all the way down to us. Our genetic structure mirrors the math of the vacuum. Because DNA is built on specific, repeating geometric ratios, it can resonate with the informational frequencies of the vacuum, functioning like a receiver for the field's underlying instructions. From the formation of galaxies down to the folding of a protein, every structure follows this same logic of informational coherence. We live inside a single, vast, optimized network.